Hello everyone, to introduce myself, my name is Tom Ewing and I'm not very good at dealing with Zoom, but I'm also a data scientist and data engineer at Add2Event. And over the last 4 or 5 years, I've spent a lot of time working with location, geography data, and there's been a lot of pain as part of that. So when David asked me to put together a presentation, I thought this was a really good subject to do. And we're going to be using two things. We're going to be using some traditional Python libraries and something called Kepler-GL, which is an open source framework from Uber. So we'll skip all that because we've lost a little bit of time. So first of all, about me, I'm a data scientist and engineer at Add2Event. I'm currently furloughed, so I'm open to funky opportunities that you might have for the next couple of months, just something to bear in mind. And just to reiterate, I'm not an expert in geography or location data, but I've hacked together a lot of my knowledge, basically in Python. And what I found is particularly when I was looking and trying to search and trying to solve my own problems, I found a lot of the kind of really good material was difficult to find. And personally, I ended up doing solving quite a lot of things that should have been quite simple in really complex ways. So I'm hoping that today I can share a little bit about how to visualize some geographic data in Python and Kepler, and hopefully save you all some pain. So we're going to have a crash course in geography. So this is only one slide, but there are 3 concepts that you need to understand in order to get the most out of this presentation. The first one is GIS, GIS, or GIS or GIS stands for Geographical Information Systems, and it's a way of cataloging, mapping, storing and analyzing geographic data. If you've worked with geographic data before, you might have heard of ArcGIS and QGIS, and they're two of the most commonly used systems for dealing with geography and maps and so on. But Python is really, really good as well, and that's what we're going to be looking at a bit later on in the presentation. The second is CRS. Now, CRS stands for Coordinate Reference System. And it's a way of representing 3D objects, for example, the Earth, in a 2D format. And most of you all have heard of latitude and longitude. That's a good example of a coordinate reference system. The third thing I want you to be mindful of is projections. Now, projections are a way of flattening the surface of the globe to make a 2D map. And when you do that, it always comes with some element of distortion. The most famous projection is Mercator, which was created in the 16th century to help sailors navigate and sail and find land and that kind of thing. But that does have the way in which that distorts the Earth is we can kind of see from the little the picture here. If something, the closer to the North or South Pole something is, the bigger Mercator makes that. So continents like Africa appear a lot smaller than they actually are, and islands like Greenland appear a lot bigger than they actually are. So those 3 things are the only things you need to know to get the most out of this presentation. When we're talking about CRS in Python, CRS will control both the coordinate reference system and the projection. So those 2 kind of aspects are kind of rolled up into one. Okay, so visualizing location data in Python. So I'm just going to take a moment here. And so I'm actually for the first time, I'm using the Jupyter Notebook slideshow functionality. So I'm not very good with it. Hopefully I won't miss anything. But yeah, so I'm just testing that out, just so that you're aware. This whole thing is a big notebook, and I'm going to be making that available at the end of the session on my GitHub. So you can go through and hopefully start creating your own wonderful maps. So we're going to be looking at 2 libraries, GeoPandas and GeoPlot. For those that are familiar with Python, GeoPandas is an implementation of Pandas for geography, and it shares a similar API and conventions. And GeoPlot is a plotting library built on top of Matplotlib and Seaborn, which are 2 Python plotting libraries. So if you know how to use Pandas, Matplotlib, and Seaborn, you will automatically be familiar with GeoPandas and GeoPlot. What we're going to be doing as part of this is making 2 data sets. We're going to make GDF-RS containing our data, and GDF-map, which is our map. So without further ado, let's get cracking on. So the first thing we have to do is import our data. And what we're actually going to do is we're going to import that as a traditional Pandas data frame. So we're going to read the CSV in. And this, if you'll notice here, this has got the GS prefix. And this is raised, this basically signifies that it's a Google Cloud, I've saved it in a Google Cloud Platform bucket. In terms of the data itself, we can see here that we've just got the head of the data frame at the bottom. There's a few things that I want to just draw your attention to. The first is location easting and location northing. Now, though eastings and northings are a coordinate reference system, a CRS, and they're part of a CRS called the Ordnance Survey National Grid, also commonly referred to as the British National Grid. So if you ever see coordinates in this kind of format, that's probably what you're dealing with. It's quite common for UK data sets to have that particular CRS, but it's less common for data sets outside the UK. If you ever download data from gov.uk or ONS, more often than not, you'll see these kind of coordinates. You'll also see longitude and latitude here and here. These are a different kind of CRS. Again, we talked about the longitude being the most common around the world. And usually if you're downloading something from Google or whatever, they'll give you the longitude and latitude. The last thing I want to make you aware of, and this is just some general background, it doesn't relate to the presentation, but it's quite nice. LSOA, here right at the end. LSOA stands for Lower Super Output Area. And it's a code used to represent a geographical area. It's basically ONS have designed this geographical hierarchy to improve the quality of geographic statistics and allow you to compare areas. I'll make sure there's a link in the material that goes out so you can have a bit more of a read about that. But yeah, it's just a kind of a little bit of background knowledge for you. Okay, so making a geodata frame. So in the previous step, we've made a pandas data frame. And what we're actually going to do now is create a geodata frame. Now they're really similar. The only aspect of a geodata frame is different is that it has a geometry column. And what we're actually doing here is we're taking the pandas data frame we created in the previous step. And what we're doing is we're saying, right, we want you to create the geometry column using the longitude and latitude. Now, when you're dealing with geography, although traditionally as laymen we say lat and long, longitude 99 times out of 100 will come first. If you don't do that, your map will look kind of the wrong way around. So that's just so you're aware. And what we're actually doing is we're saying, right, we want you to generate the geometry column using these two columns. So if we do that, what we can see is we call the data frame and we can see that it's created this geometry column with point in it. And we can see that it's got a longitude value and a latitude value. And if we check the type of that point, we can see that it's a Shapely object. Now, Shapely is a library that GeoPandas is built on top of that basically deals with creating and manipulating geography. You can have other types of object in your geometry column, most notably a polygon and a multi-polygon, but we'll get to that a bit later. Okay, so GeoPandas comes with a plot method. So as with a pandas data frame, if you want to see a chart of it, you can just do .plot in brackets, and it will show you a geographic representation of your data. We can see here that down the side and along the bottom, the scale is from 50 to kind of 62 and from -8 to 2. And that's generally a good indication that you're dealing with long and lat data. But before we can actually start to combine this data set with another data set, for example, a map data set, we actually need to set the coordinate reference system. Now, there are two ways to do this. The first way is through using very similar ways. So we basically call the data frame .crs and we set it to init, a dictionary with init as the key and EPSG 4326 as the value. Second way, which is the new way, is the same thing, except instead of init, you've got EPSG and just the number. Sometimes it's really temperamental. The new way doesn't always work. So I generally just use the old way and put up with the error message. The two CRS that we're going to be working with here are, as I mentioned, the British National Grid for the UK government kind of data sets, and the EPSG code for that is 27700, and WGS84, which is a worldwide standard with the CRS code 4326. If you ever want to know what a particular CRS code is, you can use the website epsg.io. So if we go there, and we just type in, I don't know, 27700 and click search, it will tell us what that code relates to. So that's actually a really handy website if you're dealing with any kind of form of data or CRS that you're not particularly used to. And EPSG actually stands for the European Petroleum Survey Group, who document and maintain a lot of the CRS. You learn something new every day, and that was something I learned when putting together this. So to set the CRS here, we're going to set the CRS for our data frame, and we can check it, and you should always check it, and we can see that it's given it WGS84, which is what we expected, and it's using longitude and latitude, so we can tell that's worked. So we've got our data, we've imported it. Now we actually have to make a map. Now map files usually come in one or two formats, either a shapefile or a GeoJSON format. And you can actually, there's a lot of really good maps available from the ONS Geo portal, but they come with two specific challenges. First of all, they're quite big. And secondly, as I mentioned, most of them are in OSGB BNG format, which means if you want to use lat and long data, you actually have to convert the map. But that's not a problem. What we're going to do is we're going to show you how to do that a bit later on. So we're going to use a specific map from the ONS Geo portal. So we're going to go and check that out quickly. So here we can see, okay, what this is, it's basically a local authority map of Great Britain. And if we want to download that, we can click download, and we can download that as a shapefile. So when we download it, and if we look up here, we can see that this data set is actually going to be 14 megabytes, which is quite big for a map file. The reason they're so big is because obviously a lot of people want to do quite detailed geographical calculations on them. But for us, if really the only thing we want to do is visualize it, we can actually cope with a map that's a lot smaller. And the simplest way to simplify that is with a web app called MapShaper. Now, there's a reason I put little hearts around it. It's because I love it so much. It's free and it's really, really intuitive and easy to use and useful. And what we're actually going to do, we're going to take the map that I just downloaded from the ONS website. And what we're going to do is we're actually going to go to that map, if we can find it. No, we didn't want icons, we want list. Now I've got to added, should be at the top. So here we can see, if we just select all the files, select choose, what it will do, it'll automatically import those and draw the map for us, which is really cool. So now we can see exactly what the map is that we've downloaded. We can zoom in and out, and you can see like these little bits around the coast, for example. They're obviously really, really intricate, but there's no way that we're going to want all that detail on our visualization. So what we can do is we can simplify it a little bit. Oh, I'm just trying to reach the correct level of zoom, and my system's running really slowly, but yeah, we'll get there. There we go. So if we click simplify, it doesn't really matter too much which method you use. We're just going to use the default one and click apply. It's going to calculate for a second, and we're going to get this little draggable bar at the top. And that allows us to actually simplify the geometry of that map. So you can't really see anything happening, but as soon as you get to kind of, the very bottom, you can see that it oversimplifies it. So we can cut that down to around about 50%, half of a percent of what it was. You'll notice that there's now all these little red things, and that's where the simplification process has meant that some of the polygons are kind of overlapping. But fortunately, MapShaper handles that for you. You just click repair, it will repair those. So yeah, it takes 2 seconds to take like a 200 megabyte map and kind of compress that down to around about a megabyte. You can just click export as GeoJSON, and that will actually save it down. And that map should be around about a megabyte in size. So that's MapShaper. It's one of my favorite tools. And again, I'll make sure that you get a link to that when you get the repo. Okay. So we've downloaded our map from the ONS website. We've made it a little bit simpler. What we've got to do then is import it into GeoPandas, and we can do that with the read file. So we're not reading a data frame, we're reading a JSON map file. So we use gpd.read file, and what that will actually do is create a data frame for us. Now, as we mentioned before, you've always have to set the CRS when you create a GeoPandas data frame, because otherwise it might assign the incorrect CRS to it by default. So whenever you're dealing with a GeoPandas data frame, make sure you set the CRS. And you can check the CRS here, and we can see here we've set the EPSG to 27700, and that's set it to British National Grid. If we have a look at the actual data here, we can see here that we've got a lot less columns in this data set, but we've got a polygon geometry object. Now, polygons are areas, and we can see the coordinates of that polygon are 6 7-digit numbers, which tells us, again, it confirms that it's British National Grid. And finally, if we plot that, we get a nice little kind of picture here that you can't really see very well. But that's fine. We'll get to how we can style our maps to make them look a little bit better later on. The one thing I would say about the data we've got is that the road safety data that we've downloaded from DFT doesn't actually have any Northern Ireland data. So, and the map we've got does have Northern Ireland data. It's got like Northern Ireland there. So what we can actually do is we can actually remove the Northern Ireland polygon. And again, this is exactly the same way as we would work with a pandas data frame. If we go back, we can see, oh, or maybe we can't. No, sorry. Yeah, so we can see here that there's a variable called LAD19CD. Don't ask me what that stands for. It probably stands for local authority district or something similar. But the first letter of that variable indicates which country a particular local authority is in. So what we can actually do is write exactly the same condition as that we would in pandas to remove that. So what I'm doing here, I'm saying where this column starts with N, I don't want to include it in the data set. And the tilde denotes the not, basically. So what we're saying here is where the GDF map doesn't start with N. When we plot that, we can see that it really quickly and easily removes Northern Ireland without the need to kind of put it into QGIS or whatever and start cutting and whatever. So yeah, anything you can do with a pandas data frame, you can probably do with a GeoPandas data frame as well. The next thing we have to do, so bearing in mind that our two data sets we have two different CRS systems, so they're in two different currencies. So we've got our data, which is in WGS84, which is that and long, and we've got our map, which is in British National Grid with the British National Grid coordinates. And if we want to convert our map to WGS84, we can just simply use the 2CRS method. Specify what EPSG we want to convert it to, and it will do that in a matter of seconds. And here again, we should again always check the CRS. So we can see here that our map before was OSGB 27700. It's now EPSG 4326. And we can see here, if we look at the polygon, it's changed. The coordinates have changed from OSGB to lat and long, which is good. And we've got a different projection. We've got a slightly different projection on our map as well. So before, I'll show you what the before was like. So that was what the before is like. And this is what it looks like now. So changing the CRS has also changed how our map looks. So plotting a basic map. So now we've got our data, we've got our map. Instead of kind of putting them together via a merge, what we're actually going to do is plot them as layers using the GeoPandas plotting functionality. So what we're doing here, the only reason this is in a function is so I can actually fit the function, the function and the map don't actually fit on the same screen together. So put it into a function and we'll show you the map in a sec. So with basically some really simple options, the same way that you would apply to matplotlib, exactly the same API. We turn the axis off and we set a title, and that's our base map. Then we take our data and we say, well, what we want you to do is we want you to plot that on the base map. Okay, and this is what we get. So you can see here that without any styling, can't really see the map beneath it, but we know it's there. We can see because there's not many road accidents that have happened in Scotland. So we might need to do a little bit of styling on that to make it a little bit more readable for the user. So we're going to plot a nicer map. And we're only going to include three different arguments, one of which we used before. We're going to set the marker size to be a lot smaller, and we're going to change the color to red. And we can also change the projection. So for both the map and our data, we're going to use an EPSG of 3395, which is Mercator, which is the most common projection that you'll see kind of in axes and what have you. And that's just going to make it display a little bit nicer. So here we can see this is what we're left with. There's still a lot of red dots, but we can kind of make out the geography of the UK a bit better, and the map that we're plotting on looks a little bit nicer as well. which is really good. So it's quite simple. Create the geodata frame, and you can actually plot points onto that map with using a layer. And if you wanted to plot another layer on top of this, you could do that as well. Okay, so we're now kind of thinking, you know, this map, it's nice. I mean, we've kind of done, you know, we've done a good job technically from it, but it's not really particularly easy to interpret because most of it is red and we can't really see what's actually kind of going on. A far better way to display that would be using a choropleth, which basically we've already got some areas in our maps, the local authorities, and what we could actually do is assign each of those a color based upon the number of collisions that have occurred in a particular area. And to do that, we kind of have to first of all do a little bit of prep for the data. So what we need to do is we need to find a way of assigning a point to a particular area. Unfortunately, GeoPandas and Shapely make that really easy. So this is probably the most complex slide in terms of code. What it's doing is actually quite simple, so I'll talk you through it. The first thing I'm going to do is I'm going to take my map and my data, and I'm going to convert them to a dictionary. And so, well, it's not really a dictionary. The argument is to dict, but that's actually going to convert them to JSON format, which is basically a list of dictionaries. Then what we're going to do, we're going to iterate through for each incident. We're going to check if that incident occurs in each of the local authority districts. So for each incident and for each local authority, this line here using the within method. So if our incident point is within the local authority area, we're going to set the name of the local authority to the name of the local authority in the polygon. Okay, and what that actually gives us. So then once we've done that, we can then stick that onto the data frame, which is what we're doing in this merge statement. So now we have for each record on the end, we've got this LAD19 and NM column, which basically means local authority. So we can see which local, so now in our data set, we can see which local authority a particular collision occurred in. Okay, so the next thing we need to do is a group by. And again, this works in exactly the same way as it does with pandas. What we're actually doing is creating a summary table for each local authority and the number of incidents in that local authority. And then what we're going to do is we're going to stick that data onto our map because our map has got the geometry in it and that tells us the shape of the local authorities. So when we do that, we can see here that we've now got a nice clean data frame. We've got the local authority, the polygon in the geometry column and the number of incidents. If we try and plot that in GeoPandas, all we're going to get is the geometry because it's not looking at the incidents. If we want to create a choropleth, we actually got to use another package called GeoPlot. Before we do that, we actually have to create some bins. So basically, hopefully you're familiar with the concept of binning. What we're doing here is basically saying, well, actually, if the number of collisions in a particular local authority area is between 0 and 70.5, it goes in bin 1. If it's between 70.5 and 98, it goes in bin 2. So it's kind of categorizing our numeric data. And we're actually doing that with a little library called Map Classify that automatically does that for me because I'm lazy. And what we're actually doing using the quantiles, it's not necessarily going to split it into 4. It's just going to split it into roughly proportional kind of different bins or categories. So yeah, one line of code to nicely bin your data ready for your choropleth. Okay, so once we've binned it, what we can then actually do is plot choropleth with the GeoPlot library. Now, what GeoPlot is, as I mentioned, it's built on top of Seaborn, uses a lot of the same conventions and so on, and it's a quite powerful way of plotting your data. There's millions of different kind of, well, not millions, but a lot of different options you have for charts, geographic kind of manipulations and maps and so on and so forth. It's really, really good, but what we're going to be using it for is just plotting a simple choropleth. So we're going to give it the data, we're going to tell it which column we want it to color based upon. we're going to set a color map. So we've got cool to warm, so it's going to go from blue to red. The scheme is our bin, the bins that we assigned using map classifier in the previous step. And we want a legend. We're not going to have any lines, and we're going to set the figure size to 10 and 10 to make it nice and big, so it's going to render quite beautifully. And this is what you're actually left with, what it returns, sorry. So the blue areas where there's less road traffic accidents, and the red areas where there's more road traffic accidents. As you might expect, quite rural areas of kind of northern Scotland and so on, tend to see less, whereas urban areas like particularly London see a bit more in terms of road traffic accidents as well. Okay, and that's a very, very quick, I guess, introduction to GeoPandas and Geoplot. So all of this is in one big notebook that I'm going to make available to you when I've finished this. I literally was typing it up as David was introducing me. So once I've finished, I'll just put the finishing touches to it, and I'll share the link with you in the chat. However, we are not done. So very recently, I was doing some work around visualizing some quite complicated geographical data, and it wasn't, visualizing it with GeoPandas and Geoplot wasn't easy because there was just literally so much of it. And I came across a library called Kepler-GL, which is an open source framework from Uber. And it's really, really simple to use. Most of the work occurs inside the Kepler interface. So what you do is you give it some data, and it then boots up a dashboard that you can then kind of fiddle and play with. And it's really fun. I've spent hours with it, just kind of noodling and clicking. It does, it is geographic, sorry, from your system perspective. So your laptop, it is really, really intensive. So yeah, if my stream drops when I boot this up, I'm sorry, and we'll figure something out. So before we begin, we do need to do a little bit of prep for the data. So Kepler has a time element to it as well, so you can start to do things with time. So what we're doing here is we're just creating a date time column. And we're actually going to, rather than having that in Pandas datetime format, we're actually going to convert that to a string. So what we're doing here is we're kind of formatting the time, and we're putting the date and time together, and we're making a datetime object, and then we're converting that datetime object to a string to give to Kepler. Now, another thing to bear in mind about Kepler is that it doesn't matter, it doesn't care whether it's a geodata frame or a Pandas data frame or whatever. It will generally try and make sense of whatever data that you give it. It doesn't really matter that I'm just giving it a string as a date, because it will kind of interpret that as a date time. We're going to create a value for the incident. So we're just going to set the incident to 1 to help us to visualize. And we're actually going to we're going to select some columns to put in. As I mentioned before, Kepler is really, really intensive in terms of your system. As soon as I look at it, the fan on my Mac starts going. So we're only going to put a few variables into it whilst we demonstrate it. And hopefully, when we're running it with the Zoom, it won't all break. Okay, so this is the code to create the Kepler map. Again, it's not really particularly difficult. We import Kepler-GL, and you just, whilst I remember, Kepler-GL just does have some system dependencies. So you will need to install, for example, Node.js, but the full instructions are on the Kepler website, and it's not too difficult. So yeah, we're going to create a Kepler map object by using the library, and also we're going to set is the height, and we're going to give it a dictionary telling it what data there is. So we're going to upload that our 2 data sets. The core data set we created of the road traffic incidents, and we're going to give it our local authorities choropleth as well. And what we actually want to do is we're going to save that as a file called road safety HTML. Okay. So what we're now going to do, and this is the bit where if anything's going to go wrong, it's actually going to go wrong here. So I'm actually going to attempt to open Kepler in Safari. Let's see what happens. So it's thinking about it. Okay, so it's open. David, if my stream starts to go a bit pants, will you just pop on and let me know? And I can see what I can do to rectify it. So this is the Kepler interface. What Kepler's done is created us a nice HTML file, which we can just double click and explore in our browser, be that Google. I'm using Safari because it tends to run Kepler with the least issues, but that may be slightly different for you. And what it's actually done, it's created us 3 different layers. So if you look down the left-hand side, it's kind of we've got these 3 different kind of, I guess, layers on the data. And we can show and hide those by clicking the little eye icon. So you'll see at its fundamental level, it's a map that we can play with, we can zoom in and out of all the way if we want to. And you know, there's options that we've got around the map as well. So if we wanted a light map, we can use a light map, but that's a bit bright, this thing in the morning. So we'll click with dark, but we can also turn off, for example, labels, we can turn off roads, and so on. So we've got some customization options on the base map itself, which is pretty cool. We'll start by looking at the choropleth we created. So, and just a word of warning here. So in the notebook, I kind of make it clear, but I just want to kind of bring it out. So when I simplified, remember in MapShaper, I simplified this so it would be a lot quicker and easier to display. We can see here that simplifying it does have quite an impact on the shape of it. So we're kind of missing this bit from our data. And it is really important whenever you're doing, so remember when we're checking to see which points were in which local authorities, generally you would want to do that with as higher quality map as possible. I didn't for the sake of expediency and also to show you what happens when you don't. Okay, so yeah, here we've got our choropleth. What we can actually do is if we click on the local authorities layer over on the left-hand side, we can see here that it's automatically set this up as a polygon. It's got some options around fill color, what color the line is. So if we want to change the line color to white, we can do that, and so on and so forth. The width of the line, which we don't want to set too high, obviously. So you've got a lot of customization options there as well, which is pretty cool. But for example, I mean, it's not much, at the moment, it's not really a choropleth because it's all the same color. So if we can go in and we can actually change the stroke color, which is the fill, based upon a field. So what we're going to do is change that to incidence. Oh no, we've changed the stroke color, not the fill color, apologies. So if we change the fill color to incidence, what we can then see is that it gives us a nice kind of choropleth overlaid onto an actual map. So you can actually start to explore. If we want to make it a little bit more see-through, we can. Oh, here, sorry, with the opacity, we'll close that. With the opacity, so we can make it a little bit more transparent, so we can actually see what's behind it and see which towns, roads, and so on are in a particular area. We can change the number of bins as well. So if we wanted it with 10 bins, we can change that to 10, and it will give it to us with 10 steps, and like so, for example, and we'll just keep it at 5 for now. So it's actually got a lot of really cool options that you can use to kind of explore and, you know, kind of change the, you know, the visualization of your data, which I really, really like. And also, I don't know if you can hear this, but my fan is working overtime, so my laptop's probably going to overheat soon. So what we'll do now, we'll hide that. So we've showed you the choropleth. Notice that it's created us 2 separate columns here. Sorry, 2 separate layers, one for the point and one for the instance. And the reason for that is because we had a geometry object in our pandas, GeoPandas data frame, as well as lat and long objects. So it's detected that we've got a geometry object and it's made a layer out of that. And it's detected the lat and long objects and it's made a layer out of that. Since they're both the same, we don't need both. So we're going to get rid of the point object. Okay, so we're going to change it to, we can help if we, so we're going to set the longitude and latitude here. So what we're doing, we've opened up the layer, and what we can actually do is we can actually plot our points on the map. That's pretty boring though. I mean, one of the nice things is you can actually hover over the points and it will tell you a little bit more detail about that. So it's like an online Google map. And if you want, you can actually customize which fields appear in the tooltip as well, which is pretty nice. So you've got the option there. However, I find that just point data is a little bit boring. We've kind of done that anyway. So what we can actually do is we can actually change the way in which our data is visualized. So for example, if we wanted, say, a heat map, and this will take a second, it will give us a nice heat map as well. If we want to lower the radius a little bit, we can. So we can kind of zoom in, and we can see here that, as we would expect, most of the road traffic incidents are actually occurring on roads, and we can start to see where you know, roads might be a little bit more dangerous, in particularly around junctions and so on and so forth. Another cool thing that I really like, it's actually my favorite thing, is the hex bin. And it's similar to a heat map, but what it does, it splits your map into like a series of little hexagons and overlays that onto the map. And one of the reasons why I quite like the hex bins is because you can actually look at the map in 3D and assign a height object. So if we assign height based upon the number of vehicles that were involved in the particular collision, we're going to zoom in a little bit, and we're going to set the elevation scale there. And what we can actually see is we can start to see here that where the more vehicles that were involved that are involved in accidents for a particular hexagon, it's going to be a little bit higher, which is really quite useful. So yeah, and that looks really nice. And the thing is, when you, I mean, bearing in mind this is like 4 lines of code, and it will, you know, it's really intuitive about what data it takes. You can just kind of get some geographic data from the internet or wherever, sling it into Kepler GL. And it will actually, you know, it's a really good way of kind of eyeballing data and checking where there might be any inconsistencies, stuff appearing in water or that kind of thing. The other really cool thing that I like, and let's see if I can remember how to do this, is that, actually, no, we'll talk about filtering. So we can actually add filters. So if we, for example, we wanted to filter the accident severity, so, oh, it's thinking about it. So accident severity, and I think that there's 3 values. There's 1 which is minor, 2 which is severe, and 3 which is fatality. So if we wanted to just have, well, actually, we're just going to have 1 of those. We can add a filter here. Hopefully, we'll update. It's taken a while. My Mac doesn't actually have a graphics card in it. There we go. So this is just with just serious incidents. So we can actually use the filtering aspect there. But we're going to get rid of that because it's costing my resources. My system is chewing up on my system resources. My favorite piece of Kepler is the time element. So we can, if we can, bearing in mind, if we select incidents, so we select the incidents data frame that we put in. Oh, it's running really slow now. There we go. And we can actually select the date time field. And as soon as you, Kepler detects that for you, remember we put it in as a string. What it will actually do is it will create a kind of a nice little time box at the bottom. Bearing in mind this is a year's worth of data. And when you click play, hopefully, yeah, it starts to play, you know, give you the kind of a season of giving that time aspect of doing your data as well. So for where I work at to event, a lot of the kind of events that we have are seasonal. So for example, in summer, we see a lot of people interested in marquees for weddings. And when we put that data in here, we can kind of, you see like a big spike in summer and then it kind of drops off in winter. So it's really useful for visualizing kind of seasonal data, or even over the course of a day, if you've got like a day's worth of data as well. We're actually going to stop that now. Because it's, yeah, it's hopefully not, I'll stop. Okay, what we'll do is we'll just go back. The last thing I want to show you is the map config. So when we're making all these changes to the Kepler map, what we're actually doing is we're updating a kind of the configuration. And what we can actually do is we can copy that configuration, so we can save the map in this current state. And when we're passing it to pandas, we can specify an extra argument called config and set it to that configuration, which we've copied from Kepler. And that way, when we open our HTML file, it will open in that exact format, which is really, really useful. So, you know, you don't have to spec all of the kind of the changes in that in the actual, when you're calling Kepler from Jupyter or whatever, you can actually do it all in the interface, save it, and then ensure that it loads up. So when the user looks at your map, they get a really good view of it with, you know, the nice time bits, the hex bins or whatever, and all that kind of thing. Okay, so that's Kepler. I appreciate that that's a really quick whistle-stop tour. We've made 3 maps, but as I said, all the code will be on GitHub, hopefully within the next 20 minutes, and you'll be able to download it and hopefully have a play both with GeoPandas and GeoPlot, and also Kepler yourself. I've also pulled together some useful resources at the bottom of the notebook that have some places where you can find geographic data, as well as some really useful information and guides and so on and so forth. And that's everything. I can see that there's 14 questions. Hopefully Jess has been curating those. And hopefully they're really easy to answer. So yeah, that's it. Thanks everyone. I don't know who's going to come back and do the questions. I'm assuming someone is. David, hello.
You've got me. Lucky you, mate. That was fantastic. Thank you very much. Really enjoyed it, and yeah, must admit I do like your presenting style as well, mate. It's very easy going. It's the future, Tom. It's the future.
Okay.
As you say, there is a lot of questions. I had one job at the start, and it was to point out the Q&A. And I didn't do it, but people have found it. So yeah, if you have any questions, still put them in the Q&A. I'll go through them now with Tom as best we can. One final thing just to mention to the people that are watching, there is an upvote option within the questions. So have a look at those 14, 15 questions that are there. If someone's already asked the question that you think is most relevant, just give it a little upvote and that'll just bump it to the top for us, which is cool. So here we go, Tom. I think you can see them as well, but I'll read them out and give you time to think and stuff, mate. So first question we have from Karishma. With all the tools available like QGIS, etc., what would be the advantage of using GeoPandas on Jupyter Notebook or other such tools?
For me, it's about being able to do things programmatically. So I can write a script that will take an ONS data set and transform it into the format that I want and visualize it. And I'll do that at the touch of a button. With QGIS, you kind of have to open QGIS and import the data and do all the manipulations by hand. And from my experience with QGIS, and it's been a few years since I've used it, to be fair, it was pretty slow. And I found that really irritating because I'm a really impatient man. Yeah, so I mean, also, I mean, try it, and if you're used to pandas, you'll take to GeoPandas really, really quickly and easily.
Okay, fantastic. I'm regretting saying the upvote thing because the questions are just jumping around all over the place. It looks like Ananth has asked a couple of very good questions there. So, can Kepler maps be rendered using a GPU rather than a CPU? I'm hoping yes.
Yes, so it will automatically leverage your GPU when you boot it up. You don't need to do anything. I don't have a GPU, which is why my system slowed down to like a snail. But yeah, it will. The other thing about Kepler GL is it was first written by Uber in JavaScript. So it's got anything through the browser. It's all really, really well developed, and it's going to take advantage of your system in the most efficient method possible.
Perfect. Next one's from Ali. Ali was really nice in the chat, actually, man. He clearly enjoyed your talk, so he was giving us some good.
Thank you, Ali.
So he said, Kepler GL, can I embed this into our web page?
Yes, with the best way. So there's 2 ways you can do it. If you're a web developer, you can download the Kepler GL library from GitHub and kind of put it into your web page that way, or you can create it in Python and do it via an iframe. Yeah, that's probably the simplest way, but I'm not much of a web developer. I don't, yeah, there are probably better ways to do it than what I've said, but yeah, it's completely possible. And to answer Ananth's question as well, yes, you can integrate it with Plotly, provided I don't use Plotly, but if you can do an iframe in Plotly, then you can put that into Plotly via that, which is probably the easiest way.
Okay, cool. And Anth, you've bagged 2 off there, mate. I like your style. Next question is from Linda. Is the coordinate conversion BNG to WSG84 of professional level accuracy, like for different use cases, or is it just best to keep it for different types of visualization?
It's professional level accuracy, so it's built on the same engines that QGIS and ArcGIS use. So yeah, I mean, in terms of the accuracy, it will be as accurate as your map is. So if you've got a really, really accurate map, then you'll get a really, really accurate conversion.
Fantastic. Shooting on to Jim Johnson. how do you find pre-configuring the Kepler file directly from the Python notebook rather than in Kepler itself?
Time consuming and less fun.
Wow. Less fun. Perfect. Ali Shah, mapsharer.org is awesome. Compression is great. Can I lay a CSS over this to color it? I guess that's kind of been superseded with the Kepler stuff, is it? Or?
I guess it's slightly different. I guess so. MapShaper is brilliant. The guy who made it it's completely open source. You can actually download MapShaper and run it locally on your machine. And yeah, you can do whatever you want to it. If you want to have a different CSS or mess around with it, then yeah.
Cool. Go mad. Back to Linda. Have you tried running?
There's one from Christopher.
Oh, go on, mate. Jumping in. This is what I love about you, Tom. Hey, Christopher, go on.
So does each time you change a CRS for a function, is that processing power that's required, or does it change convert to base data?
Oh,
yes, it changes and converts to base data and it processes it. But it takes, like on the data set I've got there, which was about 120,000 records, took like a second or 2 seconds. It's been optimized for speed, which is really good. So it's really, really quick.
Good, mate. I think as well. You were talking about the speed of your machine there during the demo, but it was working fine, man. You know, and you're doing a lot of things.
I was cooking eggs on it over here.
Linda's got a moment of glory. Have you tried?
Sorry, Linda. Have I tried running Kepler in the cloud? No, but that's probably a really good way. If you've got a massive data set, you could spin up a GPU instance and run it there, and it should work. But I haven't personally tried that.
Rekha, when you
Hi, Rekha. It's been a long time since I've seen. I know Rekha. It's been ages since I've seen.
Actually, she gave you a shout out on Twitter. So
thanks, Rekha.
I was going to mention it, but then I didn't want to make it awkward. So I'll let you do that yourself. So hey Rekha, when you create a heat map or bin to hexagons, can you change how these are calculated?
No, but you do have some options in terms of how big you want that heat map to be, and also some scales. So it's kind of a little bit, but not much.
Okay, thank you. Does it require Mapbox APIs? I'm not sure exactly what that reference is, to be honest. But
no, it doesn't. So you don't. It will just use a basic Mapbox thing. You don't need to actually have any. You don't need to put a Mapbox API key. I think there's an option if you want to use a specific map, you can input your Mapbox API details. And it will render on that map, but I don't bother.
Fantastic. We've got a different alley there. Can this be connected to live data feeds?
Probably. Yeah, but I think that would be beyond the Python implementation. You would want to use the JavaScript implementation, so you could pull data via an API from, for example, every X and then have it refresh. That would be a lot easier. But yeah, that would be difficult to do in Python, I think.
Fantastic. I've just realised kind of how intense this Q&A is for the speakers. Absolutely hammered. So hopefully it's all right. Give us a shout if you want a break or whatever, mate. But
no, it's fine. I'm good. I'm good.
Top of the list, Louis. Could this work alongside Databricks? I
haven't used it for Databricks, but I don't see any reason why not. It should. So you should, if you can install Kepler GL. And I would think that Databricks probably, the machine they spin you up probably already has Node. If it doesn't, if you can install Node, then yeah, it should.
Nice one. Ali Shah doesn't use Seaborn, prefers Plotly and Pandas. Is that okay?
Yeah, I mean, it's just if you've used Seaborn, the Geoplot API is exactly the same. But if you haven't, the Seaborn API is really simple anyway. So yeah, it's just keyword arguments basically. So yeah, you'll be fine, Ali. Don't worry.
Okay, Christopher Reeves. Not in the data field, so excuse my ignorance. But if you want to say visualize density of traffic instance rather than the raw number of instance, could you do that during the binning process, or do you need to process the data at the early stage to feed that in?
So I don't think you would. If you wanted to do, say, like a heat map, for example, or like the hex bins, that does a little bit of density modeling. So instead of like one spike on, remember the hex bin, one big tool spike being for one incident. That's actually for one hex, which might contain 2 or 3 incidents. So it does do a little bit of that for you. If you wanted it to visualize, if you wanted to do it your own way and then visualize it, you would have to do that at the pre-processing stage, because Kepler, as I've said, Kepler's pretty, you don't get a lot of leeway in terms of how you calculate the heat map and the hex bin densities and so on and so forth.
Thanks, Tom. We've got 3 or 4 minutes left, so we tried to keep these lunch and learn to like a 1 hour slot. It's not that we've gone to the pub and it takes 3 hours. So yeah, we're going to try and keep it to 1 hour. We'll do our best to get through a few more of these. So top of the list at the moment. This may have been answered towards the end there, but Julia Clark, do you do anything with spatio-temporal data?
Aside from showing off, because it looks really cool when stuff moves, a little bit, yeah. I mean, it's quite good for visualizing seasonality of certain things. So, you know, I personally used it to look at, you know, where gaps might be in terms of the geography from a seasonal perspective. But really, I feel like Kepler's, as I said at the kind of the presentation, I've only just recently discovered it, so I'm still scratching the kind of the surface of what it might be capable of. So yeah, no, I think I'd like to do more than that.
Could be a follow-up here, I feel. Sounds good. Robin there, just jumped to the top of the list. What's your most fun project with Kepler GL, GeoPandas or GeoPlot?
Tough one. I would say, I mean, so I'm furloughed, so I haven't had the opportunity to use it properly with kind of work data yet. So I've done a little kind of exploratory thing with a little bit of data, and it was like, oh yeah, that's good, we'll have to investigate that. But I think that would be my most fun project, because there's, you know, like maybe a gigabyte of data that I'd like to sling into it, and just kind of analyze and look at, and analyze in conjunction with, you know, the people I work with as well. I think it'd be really useful. Yeah.
Sounds good. Linda has clearly got plans to present herself. What tool did you use? To present off a notebook?
It's included in the notebook. So in your Jupyter notebook, if you select View and then Cell Toolbar and then Slideshow, you can kind of designate like each one of your notebook cells as a slide or a fragment or whatever, and then you can actually run a program that will actually convert it to a slideshow. I'll make sure that goes into the goes into the GitHub repo when I get it up and share it.
Fantastic. And in terms of that, we'll obviously follow up with people that have been on the call via email with the link and stuff like that. And we'll also stick it on the social media so people can get hold of it. So we've got 2 more questions. Oh no, there's more questions coming in.
I'll answer these really quickly.
We're going to have a clean sweep. We can try maybe one more. We'll
okay. Right. So Emma, yes. So there's a really good tool in Kepler called ARC. And if you've got 2 sets of geometry, so you've got starting point and end point, what it will actually do is draw a nice little arc between the start and end point, which is really, really cool. So yes, it will do that. But a 576 by 576 matrix, you're probably going to fry. It's probably going to fry your graphics card, and so you might want to be a little bit more conservative about what you put in. Raphael, I don't know what symbology is. Can you actually encode your symbology in Python? I'm really sorry. I'm not sure what that is. Yeah, I'm sorry. I don't know. I don't know. Last question. Max size the HTML we render without burning your laptop. Does depend on your laptop. I would say I've done on my other laptop, which does have a really bad graphics card. I think I did around about maybe 600 meg of data. But there are ways in which you can actually reduce the size of the data set that I didn't have time to do in the presentation, but I really wanted to present. So maybe that's something I can add to the GitHub repo at a later date.
Perfect. I thought we were in like a pub quiz towards the end there, mate. We were just like nailing it. We definitely won it. So, Tom, man, that absolutely brilliant. I know you worked hard on the presentation to make it look so easy. So yeah, really appreciate you giving up the time. You've been a really good supporter of the festival for years, actually. So not just today. So massive thanks to you from me and obviously everyone else that's attended.
Thank you to everyone for indulging me. It's been really good fun.
Top man, and thanks everyone for joining. We'll be back next week. We're back every Thursday at 1 o'clock. Please do, as I say, interact with us, share your feedback, and also, share with your own network, please, because as I say, we do go to a lot of hard work to put these on, and be great to see it growing. So
one more thing, I will tweet. So I will tweet the location of the repo when I finished it in about 10 minutes. So Dave, if you can retweet that from the Data Science Festival.
We are on it, mate. Do not panic. Do not panic. Awesome. Okay. Thank you very much, everyone. We're going to leave it here. And as I say, we'll hopefully see you in future weeks. So once again, thanks, Tom.
Thank you.